Algebra 1 students, as the school year gets close to a close, we have one more chapter. One of the most important ones. You'll want to learn it well. Quadratics. Today, we're going to start by looking at graphs of quadratics and their properties. The big idea for today's lesson is understanding the way a quadratic can be written. The standard form you can see here is y equals ax squared plus bx plus c, and how that affects the graph, the different values, especially for a and c will be the two we'll focus on the most today. Now let's start with a little bit of terminology. First of all, the parent function. The parent function for a quadratic is the graph y equals x squared. You can see it right here. It has what's called a vertex. That's where the graph essentially changes direction. And in the parent function, that vertex is at the origin, 0, 0. And it also has an axis of symmetry. That's the line that where we have symmetry of the parabola on either side. And so in this case, that axis of symmetry would be at the line x equals 0. All right, some things to know. When you're graphing from standard form, if you see an a value that's positive, the parabola opens upward, and the vertex would therefore be a minimum, and you can see that example right here. If the a term, the lead coefficient, the x squared portion of it, is negative, then the parabola opens downward, and the vertex would be a minimum. And that's vertex, not vertexed. I don't know who did that. I'm blaming Mr. Thornburg. But in any case, here's the way, maybe a simple way to remember this. If a is positive, it's happy. And if it's happy, we have a smiley face, like you see here, where when a is negative, it's down, it's sad. A frown face would open downward. Kind of lame, but it helps you remember. All right, so let's take a look at this, find the vertex, and tell if it is a minimum or a maximum. So first thing I need to do is figure out, okay, well, this is opening upward. The vertex is this point right here, which is the point, the ordered pair 1 and 2. And then the question is it a minimum or a maximum? Well, it's at the bottom of the graph, so it's definitely a minimum. Let's take a look at number 2. This time we have a parabola opening downward, and you can see that the vertex would be right here. And that ordered pair is, of course, -1 and 4, and that's the highest value, the highest y value for the entire graph. So we would call that point a maximum. All right, here we go. We're going to do some graphing of parabolas. Y equals 3x squared. Now, here's the way I think you should start. Let's do the t-chart that we're used to doing when we graph things. And what we're going to do is pick values for x like -2, -1, 0, 1, and 2. Now I wrote a y right here. Really what I should be doing is putting 3x squared right there, which is y. And so what I'll have here is 3 times -2 quantity squared. That's 3 times 4, or just simply 12. Next I would have 3 times -1 quantity squared. That's 3 times 1, or 3. Then I'd have 3 times 0 squared, which would be 0. And then you're going to start to see when we go to the positive values, since we're squaring that x value, that we start to see repetition in some of our numbers. So a 3 and a 12. Now, as you would expect, since this is in fact a graphing problem, we'll go ahead and graph. -2 and 12. Now I know 12 is off my screen just a little bit. I'm going to kind of just estimate it to be up there just so I have an idea where it might be. Then -1 and 3 would be right there. 0, 0, 1, 3, and then finally 2 and 12. Now, this is a parabola. It's a pretty steep parabola, but it still is definitely a parabola, and hopefully you're having better luck than I am at drawing it. This will be my final attempt. If this doesn't work, I'm just sticking with it anyway. All right, I'm going to roll with it. It's terrible, but that's what it is. All right, now it says to identify the domain and range. Now remember, folks, domain means x values, where range is referencing all the possible y values. All right, so what we're going to look at here is a domain. Well, what values could I enter and get some result back? Well, there's really no limit. We can go as far left and right as we want. So we would just say something like negative infinity to positive infinity. Some of you may prefer to write it this way and just say all reals. In other words, any number would work. The range, though, is limited. The smallest y value I have is that vertex right here. Okay, that's the vertex. It's also a minimum, which means the lowest y value that I have is 0. So I would just say y is greater than or equal to 0. Let's take a look at another one. Y equals negative 1/2 x squared. Again, we're going to set up our t-chart. And I like those values of -2, -1, 0, 1, and 2. They're pretty good values for us, although I think there's an argument going with even numbers here could be wise. So maybe you'd prefer to do -4, -2, and 0 just to avoid the fraction situation. And again, I have my habit of just writing x and y, but I want to go ahead and include what we're doing in the middle here. So I will do that. So this will be -1/2 times -2 squared. -1/2 times 4 is -2. This will be -1/2 times -1 quantity squared, which would of course be -1/2. This is -1/2 times 0 squared, which is 0. And now is when we start to see repetition in our numbers. -1/2 times 1 is -1/2. And then -1/2 times 2 squared would be -1/2 times 4, or -2. All right, so again we have a vertex right here at the origin, -1 and -1/2. 1 and -1/2 are points. Also we have 2 and -2. Excuse me, -2, -2, and 2, -2. It might have been smart to go ahead and include 4 in this. I kind of like doing 4 because it gives us that one extra space to kind of see the shape a little bit better. 1/2 of 16 is 8. We need to make it negative, so it's -8 right there. And there would be a point of symmetry right across over there. So our graph would be something like this. Give myself a B-, which is better than the D- I got on the previous page. All right, let's talk domain and range. Domain. Again, we could plug in any x value that we want. So our domain is all reals. Our range is restricted. This time we see that this vertex point right here is a maximum value. So we know that the y values are never going to be more than 0. So we would just say that y is less than or equal to 0. All right, let's take a look at number 5. This one we're changing gears just a bit, and we have a little bit of an adjustment to our graph. We can actually keep doing things in a very similar fashion. No, we're going to do -2, then we'll go ahead and put our spot where we can do a little work and then see what the result is. And I have no idea why I put -2 there when I meant x. Someday I'll do a problem without making a mistake. I don't think today's that day though. -2, -1, 0, 1, and 2. So then we'll have -2 times -2 squared plus 3. All right, so this is -2 times 8. That's -8 plus 3 would give me -5. All right, -2 times -1 squared plus 3. That's -2 plus 3. That would be 1. 0 would give me 0 plus 3, so that's going to be 3. and then we'll continue on. Negative 2 plus 3 is negative 1, and I didn't write my negative right there. Oh, that's because it's positive. That would be the reason I didn't write it. And that's also positive 1. And then we'll have negative 2 times 2 squared, which would be negative 8 right there, plus 3, or negative 5. All right, so here we go. This time the vertex is at a different spot, 0, 3. And this time the graph is opening downward. So I'm going in and plotting all these points that we just found. Our graph should look like this. Now we have one more thing we need to do, and that is to consider the domain and range. And with all of the parabolas that we're doing, as long as they stay either opening upward or downward, which is everything we will be dealing with in this course, we can just say that our domain is all real. So you can plug in any x value you'd like. The range, though, has some restrictions. Now I know that the vertex point right there is a maximum, and remember, it's at the point 0 and 3. So what I know about the y values is that y has to be less than or equal to 3. All right, for number 6, what I want you guys to do is go ahead and pause the video and work through this on yourself and then check your answer. No, I'm serious now. Pause that video. I meant it. Pause it, do the work, and then come back to me. I'll be back. All right, folks, you can see my solution right here. Yours should look quite similar. If you have any questions, you'll have a chance to ask them in class tomorrow. We'll also do the last two together. I thought that would be better to work through them together. We're going to use Desmos Graphing Calculator. Hope you have a great day.